Hello, this is OCR Further Statistics. We're in Probability 1, Arrangements and Counting, and the fourth and final video on probability. There are 2 pause points in this video to give you time to try the questions. Don't watch the solutions until you've had a go for yourself. This is just what you learned about probability in Year 7 or earlier. The only difference now is that counting the options is much more complex. When you've got a situation involving a complex count, you will probably find it easier to count and then work out the probabilities, rather than starting with probabilities and applying and or rules. Here's your first example. Pause the video while you have a go at this question. OK, for part A, let's start by considering the girls. I've got girl 1, girl 2 and girl 3. There are 3 factorial ways of arranging them. And then I've got to put the boys in, and the boys need to go in the gaps. Now I've got 4 gaps, including the ends, but I haven't got complete freedom about where I put the boys, because I must put boys into these 2 gaps here to keep the girls separate. So in fact the only choice I have is whether to use this end or this end. So I have exactly 2 choices about which 3 gaps I use. But when I put the boys in, there are 3 boys and I've got 3 factorial different ways of arranging them. So that gives me 3 factorial times 2 times 3 factorial, which is 72. So that's the number of arrangements with the girls and boys sitting separately. There are, of course, a total of 6 factorial ways of arranging them altogether. So the probability that the girls and boys are all separate is 72 over 6 factorial, which simplifies down to 1/10. For part B, it's probably easier to work out the probability that Terry and Tara are together and then subtract from 1. We're not told that the girls and boys have to alternate, so as I have got 2n students, that's 2n factorial ways of arranging them. If we need Tara and Terry together, there are now 2n minus 1 distinct items, so that's 2n minus 1 factorial ways of arranging them. But we mustn't forget that they can be either way round, so that's actually 2n minus 1 factorial multiplied by 2. So the probability that Tara and Terry are together is 2n minus 1 factorial times 2 over 2n factorial. So simplifying this, 2n minus 1 factorial over 2n factorial is 1 over 2n, and then I've got 2 there, so I've got 2 over 2n, which is 1 over n. So that's the probability that Tara and Terry are together. So the probability that Tara and Terry are separate is 1 minus 1 over n, which is n minus 1 over n. OK, here's the second question. Pause the video while you have a go at it. OK, for this one we just need to treat the girls and the boys separately. For the girls, I've got 13 girls and I want to choose 8 of them. So 13 choose 8, That's 1,287 different ways of choosing 8 girls. For the boys, I've got 15 boys and I'm again choosing 8, and that is 6,435 ways. So 1,287 ways of choosing the girls multiplied by 6,435 ways of choosing the boys, giving me a total of 8,281,845 ways of choosing the girls and the boys using the multiplication principle. That's the end of this video on probability and the end of this section.